solving simple equations with Adam Maths Tutor. Here are some of the more simple beginner questions. An equation is a mathematical statement that shows two expressions are equal, often containing an unknown variable such as x in this first example. The goal, when solving, is to find the value of the unknown variable that makes the equation true. There are a couple of different ways of accessing these types of questions. The first and easiest way is to relate them to function machines. You can describe what's happened to your input x on the left-hand side of the equation. So when x goes into the function machine, we added 7 to it, and this was equal to or gave us the other side of the equation, which is 13. So applying the inverse function, we can start with 13 and work backwards towards x. So the inverse of adding 7 would be to subtract 7, and 13 minus 7 will give us our unknown value for x, which would be 6. The slightly trickier method involves balancing equations, and this will be more helpful to access some of the harder types of solving equations that come up a little bit later on in this topic. This just treats the equals as the middle of your equation, where you have a left-hand side of the equation and a right-hand side of the equation. And since we're solving to find x, we essentially want to make x the subject. So isolate the variable by using inverse operations to eliminate everything on the left-hand side but x. So in this case, I can see that x is being added to 7. So to eliminate the 7, I can subtract 7 from the left-hand side. But since the equation is balanced, anything that I do to one side of the equation, I also need to do to the other side of the equation. Subtracting 7 from the left-hand side will just leave me with x, and 7 from the right-hand side will be 13, subtract 7, which is 6. I'll be using the method of balancing moving forwards with all of these questions. As I've said, this gives me greater access to some of the more difficult questions that come up a little bit later on in the topic. For the next question, solve 7y equals 63. We need to find the value of y that makes this true. On the left-hand side, we can see that y is being multiplied by 7. To eliminate the multiple of 7, I'll need to apply the inverse operation, which would be to divide by 7. Since I'm doing this on the left-hand side, I would also need to do this on the right-hand side, leaving me with y on the left-hand side, and 63 divided by 7 will give me 9 on the right-hand side. For the last question, we need to solve to find c when c over 4, which is c divided by 4, equals negative 2. To eliminate the denominator, or the division, by 4, I'll apply the inverse operation of multiplying by 4. Repeating this on the right-hand side will leave me with c on the left-hand side, and negative 2 multiplied by 4 is negative 8. You can check your answers by substituting these values back into the original equations to check that they hold true. For example, if I replace x for 6, we can check to see that 6 plus 7 does indeed give me 13, which it does. For the next question, if I replace y with 9, 7 lots of 9 is 63. And for the last question, if I replace c with negative 8, then negative 8 divided by 4 will give me negative 2. On to the intermediate questions with an increase in difficulty. We're moving from one-step equations, seen in the beginner questions, to two-step equations shown here. What we mean by that is now looking at the left-hand side of the equal sign. Not only am I multiplying x by 3, I'm then adding 8 to it afterwards, hence 2 steps rather than 1. We need to apply the inverse operations of BIDMAS. Using BIDMAS, 3x plus 8 will involve multiplying x by 3 first, before adding 8 to our result. So applying the opposite and the inverse operations, the first thing I will need to do is to eliminate positive 8 by subtracting 8 from the left-hand side and balancing it by subtracting 8 from the right-hand side. This will leave me with 3x on the left-hand side, and 2 subtract 8 is negative 6 on the right-hand side. Now I can see that I'm left with 3 lots of x, and I can eliminate the multiple of 3 by dividing through by 3 on the left-hand side and the right-hand side, leaving me with x equals, and negative 6 divided by 3 is negative 2. On to the second question. Y is being divided by 3, and then I'm subtracting 5 to give me 4. To find y by isolating it and making it the subject, I will first need to add 5 to the left hand side, which means adding 5 to the right hand side. This will give me y over 3 is equal to 4 plus 5 is 9. And to eliminate the denominator or the division by 3, I will multiply the left hand side by 3, which means multiplying the right hand side by 3 to keep this equation balanced. Therefore y is equal to 9 multiplied by 3, which is 27. And for the last question, x is being multiplied by 10 before subtracting 2. So the inverse to isolate x would be to add 2 to the left hand side and the right hand side. 10x is equal to 5. And this is a common mistake or misconception at this point, where people see 10 and 5 and automatically just divide the larger number by the smaller number and say that x is equal to 2. But actually, to isolate x here, I'll need to divide by 10 on the left hand side, which involves dividing by 10 on the right hand side. So you can see when solving equations, we don't always do the larger number divided by the smaller number. We just need to make sure that we check what we're multiplying x by before applying the inverse to both the left hand side and the right hand side. Therefore x will be equal to 5 divided by 10, which is the same as 0.5 or 1/2. On to the advanced questions, some of the trickier questions that you're likely to find on this topic. Firstly, we have 24 equals 4 lots of, and we have the introduction of a bracket 2x minus 5. There are a couple of different ways of approaching these types of questions involving brackets. The most intuitive way may be to start by expanding the bracket first, which will work, or we could think of this as 2x minus 5, which is then being multiplied by 4. So applying the inverse would first involve dividing by 4. Notice that the variable x is now on the right hand side of the equation, which is slightly different to the format of the other questions that we've looked at where it's on the left hand side. It doesn't matter which side of the equation it's on. The good thing about doing balancing is if we say we're going to divide by 4 on the right hand side to eliminate this multiple of 4, we will then just divide by 4 on the left hand side. And you can actually complete the right hand side or the left hand side first. So this will leave me with the bracket 2x minus 5, which no longer needs to be written as a bracket now that I've divided through by 4. And that will be equal to the left hand side, 24 divided by 4, which is 6. Again, I'm focused on isolating x or finding x. So I'm left with 2 lots of x and then subtracting 5. So the inverse would be to add 5 on the right hand side to leave me with 2x, but will also involve adding 5 on the left hand side. 6 plus 5 is 11, and this will leave me with 2x on the right hand side. And finally, to find x, I'll need to divide through by this multiple of 2. So dividing by 2 on the right and left hand side will leave me with x is equal to 11 over 2. You can write these as decimals, but it would actually be preferable to write them as simplified fractions, especially if you end up with a slightly trickier fraction which gives you a recurring decimal, such as 3x equals 7. You wouldn't want to spend time working out what 7 divided by 3 is as a decimal on a non-calculator question or paper, when you can just leave your answer as 7 over 3. You just need to make sure that if this fraction can be simplified that you do. For example, if I had 6x equals 14, x would be equal to 14 over 6, which simplifies to give me 7 over 3. I would need to make sure that I wrote this simplified version down rather than leaving it as an unsimplified fraction 14 over 6. On to the second question. On the left hand side, we're multiplying k by negative 3 before adding 2 to it. I can start by isolating negative 3k by subtracting 2 from the left hand side, which means subtracting 2 from the right hand side. This will leave me with negative 3 lots of k on the left hand side, 15 on the right hand side. To isolate and solve to find k, I can divide through by negative 3, which means that k would be equal to 15 divided by negative 3, which is negative 5. And for the last question, 3 equals 9 minus 4k. Subtracting 9 from both sides will allow me to isolate the negative 4k. 3 subtract 9 is negative 6, and this would be equal to negative 4k. And dividing through by negative 4, negative 6 over negative 4 is 6 over 4. which is equal to k. And this is an example where I'll be able to write this as a simplified fraction, where 6 over 4 is equal to 3 over 2. Therefore, k is equal to 3 over 2. Here's a question that I've completed earlier. It appears as though I've made some mistakes. Pause the video and see if you can spot what they are before writing some corrections in the comments below.
Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with topics or finding maths difficult, subscribe and turn on notifications to receive regular updates about new video tutorials and other useful content. You can visit and follow all of my socials by clicking the links in the description below.